Hello students, I hope you are doing fantastic out there, isn't it? So today we'll see the theorem related to diagonals of parallelogram. Okay, so let's begin. So this is the question: prove that the diagonals of parallelogram bisect each other. Okay, so this is a parallelogram. A, B, C, D is a parallelogram, and BD and AC are two diagonals, isn't it? So we are asked to prove that diagonal BD and AC bisect each other. Okay, so let us understand the word bisect first. Okay, what does the word bisect mean? Let us understand this first. Okay, suppose if I have a 10 centimeter long straight line, this line segment is 10 centimeter long. If I say divide this line segment into two parts, divide this line segment into two parts, which means this can be 2 centimeter, this can be 8 centimeter, isn't it? Or you can say this can be 4 centimeter, this can be 6 centimeter, or I can say this can be 7 centimeter, this can be 3 centimeter. In innumerable ways we can divide this straight line, isn't it? In infinite number of ways we can divide this straight line into two parts. Okay, but if I say bisect this line segment, this means this 10 centimeter long straight line, 10 centimeter long, okay, 10 centimeter long straight line, when bisected, each part must be equal to 5 centimeter. This part 5 centimeter, this part 5 centimeter. The word bisect means to divide into two equal parts. Okay, similarly, if this is 100 centimeter long straight line, okay, this line segment is 100 centimeter long. If I bisect this line segment, each part must be equal to 50 centimeter. This part must be equal to 50 centimeter. This part and this part must be equal. Okay, I hope you got this. Bisect means to divide into two equal parts. Now let us see some key elements that will be needed to prove this theorem. Okay, suppose we have straight line parallel to each other. Okay, these two lines are parallel to each other, and if I draw a transversal like this, then these two angles will be equal to each other. These two angles are called alternate angles. Okay, alternate angles. Which means if this is 45 degree, this is just an example. Okay, this must be equal to 45 degree. If this is 30 degree, then this must be equal to 30 degree. Alternate angles are equal to each other. Okay, and if we intersect two straight lines, suppose I have a straight line AB and another straight line CD. Okay, AB and CD intersect at this point. This point of intersection is named as O. Okay, point of intersection is named as O. If AB and CD intersect at the point O, then this angle must be equal to this angle. If this is 60 degree, this must be equal to 60 degree. Example, okay, just an example. 60 and 60, opposite angles. These angles are called opposite angles. Okay, this angle must be equal to this angle, which means 180 minus 60 is 120, isn't it? So this angle must be equal to 120 degree, and this angle must be equal to 120 degree. Okay, because a straight line is 180 degree, isn't it? 180 degree. So this total angle is 180. So 120 plus 60 is 180. 120 plus 60 is 180. Okay, so this angle must be equal to this angle, 60 60. This angle must be equal to this angle. Opposite angles are equal to each other. Okay, now let us see some properties of triangle. Suppose we have two triangles like this. Okay, and suppose this angle is equal to this angle. These two angles are equal to each other. Okay, angles are equal. Now again this angle is equal to this angle. Again angle are equal. Okay, and this side is equal to this side, and one of its side is equal. So if angle sides are equal, then these two triangles are congruent triangles. Okay, congruent triangles. Congruent means if I pick up this triangle and place over this triangle, okay, this triangle will be exactly overlapped, which means each side of this triangle will be equal. Okay, this must be equal to this, this must be equal to this side must be equal to this side must be equal to this, and this side must be equal to this. If two angles and one side are equal to each other, then these two triangles will become congruent to each other. If angle, side, angle are equal, then also we can say these two triangles are equal. If side, side, side are equal, then also we say the triangles are congruent to each other. Okay. Now let us prove the theorem. So given, what is given to us? Let us first write that two diagonals AC and BD of parallelogram ABCD intersect at the point O. So this is given to us. Okay, two diagonals AC and BD of the parallelogram ABCD intersect at the point O. These two diagonals AC and BD of parallelogram ABCD intersect at the point O. Okay, this diagonal and this diagonal intersect at the point O. This is given to us. So to prove, what we are asked to prove? Bisect, isn't it? Word bisect means diagonals divide into two halves, two equal parts, isn't it? Which means AO equal to OC. Okay, diagonal AC, total length is AC, so upper part is AO and the lower part is OC. This upper part must be equal to the lower part OC. AO must be equal to OC. Okay, bisect means this diagonal is divided into two parts, AO and OC, and AO must be equal to OC. AO must be equal to OC. Okay, and BD, BO must be equal to OD. BO, length of BO must be equal to length of OD. Okay, this is what we are asked to prove. So let us prove this. Proof: in triangle AOD, the upper triangle, okay, AOD, in triangle AOD and triangle BOC, okay, lower BOC, okay, and triangle BOC. First, since AD parallel to BC, isn't it? This AD and BC are parallel to each other because these two are the opposite sides of parallelogram ABCD, isn't it? Opposite sides of parallelogram are always parallel to each other. Opposite sides of parallelogram are always parallel to each other, isn't it? Opposite sides of parallelogram are always parallel to each other. Okay, so AD and BC are parallel. AD parallel to BC. This is the symbol for parallel line. Okay, AD parallel to BC, and AC is transversal. AC is transversal, isn't it? So if we have two straight lines parallel to each other, and if I draw a transversal like this angle and this angle will be equal to each other. These two angles are called alternate angles, isn't it? So this angle and this angle will be equal to each other. Alternate angles, isn't it? AD and BC are parallel and AC is transversal. So this angle must be equal. This angle and this angle must be equal. This angle and this angle must be equal. Therefore, angle CAD, A must be in the middle, okay? Angle A, CAD, angle CAD must be equal to angle ACB, isn't it? ACB, alternate angles. Now CAD, OAD, isn't it? CAD and OAD, same thing. That is angle OAD equal to angle OCB. OCB, okay, alternate angles. Now you can see AC and BO intersect at the point O, isn't it? Since AC and BO intersect, AC and BD, okay, AC and BD intersect at the point O. AC and BD intersect at the point O, isn't it? Which means if two lines intersect like this, then this angle must be equal to this angle, opposite angles, isn't it? Which means this angle will be equal to this angle, okay, opposite angles. So angle AOD, angle AOD means this angle must be equal to angle BOC, this angle, isn't it? Equal to angle BOC, opposite angles, okay. Now since BC and AD are equal to each other, BC and AD are opposite sides of parallelogram ABCD, since BC and AD are opposite sides of parallelogram, opposite sides of parallelogram ABCD, isn't it? ABCD, okay. BC and AD are opposite sides of parallelogram ABCD, isn't it? Let me give an example, okay. If we have a rectangle like this side and this side are the opposite sides of rectangle, these two sides will be equal to each other. This side and this side are opposite sides of rectangle, these two sides will be equal to each other. Similarly, this side will be equal to this side. Opposite sides of parallelogram are also equal, like in rectangle, okay. Therefore BC equals to AD, okay. BC and AD are equal because BC and AD are opposite sides of parallelogram. Now in triangle AOD and BOC, okay, AOD and BOC, in triangle AOD and BOC, we saw this angle, okay, this angle equal to this angle, this angle is equal to this angle, and this angle equals to this angle, and this side equals to this side. Therefore you can say triangle AOD is congruent to triangle BOC, isn't it? Angle side congruency, isn't it? Criteria for congruency is angle side. Two angles, 1 and 1. This 2, okay. These two angles, okay, are equal. This angle of triangle AOD is equal to this angle of triangle BOC, and this angle of triangle AOD is equal to this angle of angle BOC. Two angles are equal and one side is equal. BC equals to AD. This side and this side are equal. So these two triangles are congruent to each other, which means, this means, therefore each side, if two triangles are congruent to each other, means one triangle when placed over the other triangle, the triangles will be exactly matched, isn't it? Overlapped. So you can say each side of these triangles are equal to each other. Okay, therefore AO equals to OC. AO and OC are equal because this side of the triangle is equal to, let me draw 3 lines. Okay, this side of this triangle equal to this side of this triangle, 2 sides. This side of triangle AOD, AO is the side of triangle AOD, and OC is the side of triangle BOC, isn't it? These 2 sides are equal. Okay, congruent triangles have equal sides, isn't it? So AO and OC are equal. Similarly, and BO and OD are also equal. BO equal to OD. Okay, this side, okay, must be equal to this side. BO is the side of triangle BOC, and OD is the side of triangle AOD. You can see AOD and BOC are congruent triangle, which means their sides must be equal. So AO must be equal to OC and BO must be equal to OD, which means diagonals AC and BD bisect each other, isn't it? Therefore diagonals AC and BD bisect each other. Okay, this half of the diagonal is equal to this half of the diagonal, and this half of the diagonal BD equals to this half of the diagonal BD. So I hope you got this. Okay, this much for today. Thank you so much. Stay connected. Okay, I'll see you in the next video. Thank you.